sodium carbonate.
Yeah,
Sure.
that's so hopefully, hold on.
Don't worry, collateral damage is okay.
There we go. Okay, so somebody get me, there should be like a spray bottle of that cleaner or something randomly floating around in my room that sprays something. That'll work.
Just spit in the air.
No, that's gross. It's biology.
Good word.
Okay, so we can see this, right? So now, notice that this is coming in here and it's hitting that light. So, and it's hitting the water. So what's it doing? Bending up or bending down?
Bend down.
Bending down. Why?
Because the light is going slower.
Water is more
Dense.
optically dense, right? Now, but you have to remember, when you look at this, if you're the swimmer down here at the bottom, when you're the swimmer, what are you going to see? Are you going to see the light here?
No.
You're going to trace this back, and you're going to think the light source is up here, because that's what you're seeing. So if you're here, light's going to come up here, boom, you're going to think it's up here. Now, I'm going to do something different. So now I'm going to start this, and I'm going to try and shine it up through here and see what happens. So if I change that angle, you should be able to, there we go. Okay, so notice that up here, that, let me kind of get this quick spray. Okay, so it's coming through the plastic, through a little bit of the water, and then it's ending up there. But if I change that angle, what do you notice happens? Total internal refraction. So what happens is this. So this light is coming in here, and let's try this. Okay? So that light is hitting this interface, and instead of going out, that light is getting refracted back. Now, but if I go to a different angle, then you'll see that starting to show up there that you didn't see before. So what's happening here is that there's an angle, and we're going to be able to calculate that. When you have total internal refraction, that only happens when you go from a more optically dense material into a less optically dense. If I'm going from the air into the water, I'm never going to reach a point where this is going to hit and it's all going to stay up here. Like all of that light is just going to bounce off the ceiling. It's going to act like a mirror. It's not going to happen. That's only going to happen when you have a situation where you're going in terms of total internal refraction. It won't happen going from air into water, but it will happen if I'm going from water into air. So basically what happens is that it hits this surface, it doesn't bounce out, all that light gets sent back in. See the difference between the two? So if I'm going from air into water, it's going to bend down all the time. If I'm going from water into air, I can have it where all of that energy stays in there. Got the visual? Know what I'm talking about? Okay, back we go.